Computer vision is a subfield of artificial intelligence, AI, and computer science that focuses on enabling computers to interpret and understand visual information from the world. It seeks to replicate the human visual system's ability to extract meaning and insights from images and videos. Computer vision involves the development of algorithms, models, and systems that can analyze and make decisions based on visual data. Key components and concepts in computer vision include 1. Image processing *. This is the fundamental step in computer vision, involving tasks like image enhancement, filtering, and transformation to prepare visual data for analysis. 2. Feature extraction *. Identifying and extracting relevant features from images, such as edges, corners, and textures, to represent objects or patterns. 3. Object detection *. Detecting and locating objects of interest within images or video frames. Object detection is crucial for applications like facial recognition and self-driving cars. 4. Image classification *. Categorizing images into predefined classes or labels. This is commonly used in tasks like recognizing objects, animals, and handwritten text. 5. Semantic segmentation *. Assigning semantic labels to each pixel in an image, effectively dividing it into regions with different meanings. This is used in medical imaging, autonomous navigation, and more. 6. Optical character recognition, OCR ***. The ability to recognize and extract text from images, making it possible to convert printed or handwritten text into digital content. Machine learning and deep learning *. Machine learning techniques, especially deep learning, are used to train models for tasks like image classification and object detection. Convolutional neural networks, CNNs, are commonly used for computer vision tasks. 8. ** 3D computer vision *. Extending computer vision to the 3D space, allowing for depth perception and the reconstruction of 3D objects and scenes from 2D images. 9. Video analysis *. Analyzing and interpreting video streams, including tasks like tracking objects, recognizing actions, and detecting anomalies in surveillance footage. 10. Applications *. Computer vision has a wide range of applications, including facial recognition, autonomous vehicles, medical image analysis, robotics, augmented reality, and more. 11. Challenges *. Challenges in computer vision include handling variations in lighting, viewpoint, and occlusions, as well as achieving real-time processing in some applications. Computer vision has made significant progress in recent years, thanks in large part to advances in deep learning and the availability of large labeled datasets. It is a key enabling technology for many AI-driven applications and is contributing to innovations in areas like healthcare, entertainment, transportation, and more.